Hey, awesome people. Mr. C here with you with a fractions video. Make sure if you learn anything new at all, click that like and subscribe button. Join us as we continue making math understandable and challenging. This video is going to be our practice problems video for adding fractions with unlike denominators using models. Again, this is our practice problems video. The teaching video is in the description below. You'll also find in the description below all things second grade, third grade, and fourth grade fractions. This is our first fifth grade standard we are working on in regards to fractions. All right. Parents, teachers, also in the description below, you will find two really important links. They are for a program called iExcel. iExcel is a program I've used in my classroom and loved. Students were able to track their learning. They were able to get independent practice and to master skills that we were working on in class. It is an awesome program. Two links for you. One of them is a 7-day free trial, and the other one is a 20% off a monthly or annual memberships. Check those out. I love this program. Okay. Again, this is our practice problems video for adding fractions with unlike denominators using models. Let's get started. Well, here we are, ladies and gentlemen, with our very first problem. Before we get started, make sure you have a growth mindset. This is a new skill for a lot of us that we're learning, and that's going to take some hard work, okay? You are going to make mistakes. You are going to be challenged. Be okay with both those things. Seek them out. Know that by asking good questions, by making mistakes, by drawing the models, by practicing, you will get better, okay? So stick with me on these and do your best. Here we go with our first one. We've got 2/3 plus 1/4. Again, this is our practice problems video. That means I'm going to go through these a little bit quicker than I would in teaching video. So if you missed that, it is in the description below. So we've got 2/3 plus 1/4. So what we need to do is we need to draw some models. Okay, we need to draw models to represent these two fractions. So I'm going to draw 2/3, and then I'm going to draw 1/4. So got my two models here. They are equal sized. First model is going to be broken into 2/3. So there's 1/3, there's 2/3, shading this in. And again, right now, the reason we're not able to add these two fractions right by just looking at them is because their denominators are different. Because their denominators are different, they are unlike, we cannot add them without doing some extra work. And the reason for that is because both models need to be broken into the same number of pieces. This model's in 2/3, this model's in 1/4. There's 3 equal sized pieces. There's 4 equal sized pieces, okay? So this is what the models look like originally. Well, the way I would draw them. Some of you draw the lines horizontal, and that works as well. But what we are going to do is we are going to draw these models one more time underneath here. So I'm just copying them. What we are going to do is we are going to divide the very first model, which represents 2/3, and we're going to divide that into 3 equal sized pieces, and we're going to do that vertically, okay? So we're going to do that vertically just like we did to represent 2/3. And we have to do this one vertically. I do it vertically just to stay consistent. I always do the first model vertically, just that way I'm consistent when I'm teaching it. The second model, we need to divide it into 4 equal sized pieces, but we need to do this horizontally. Okay, we have to do this in order to represent whenever we show thirds on this model and when we show fourths on this model. They have to be different directions, okay? So color in 1/4. There we go. All right, so would you agree this here's 2/3, this here's 1/4. Now what we need to do is I need to represent fourths onto this model. Okay, so I'm going to draw horizontal lines on this model to represent fourths. Okay, so there is one of them, 2, 3, and 4. So I have represented fourths horizontally. 1, 2, 3, 4. Over here on this model, I need to represent thirds because the vertical lines represent thirds. So there's 1, 2, and 3. Notice 1, 2, 3. That's thirds. 1/3, 2/3, 3/3. Now, let's see if we have equal size pieces, an equal number of pieces in both of these models. Let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 equal size pieces. And then we've got, whoops, I actually want to change the color real quick. Sorry about that. Write that in purple. Let me erase it. Sorry. Stick with me. Okay. There we go. So I wrote that one in purple. Now let me write this one in pink. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, good news is both of them have 12 equal size pieces. Why did we do that? We did that because we cannot add these fractions without having common denominators. Okay, it makes our life so much easier if the denominators are the same. Okay, now count how many are shaded in each model. How many are shaded in purple? 1, 2, 3, 4, 5, 6, 7, 8. How many are shaded in pink? 1, 2, 3, and there we go. All right, couple things I want to point out. 8/12. This is equal to 2/3. All right, this was not magic how this happened. 3/12 is equal to 1/4. This is not magic how this happened. What we did was we found common denominators by dividing these models into equal size pieces. We created equivalent fractions. 2/3 is equal to 8/12. 3/12 is equal to 1/4. Both of these fractions are equivalent and equivalent. Why did we do that? Because by creating equivalent fractions that both had denominators of 12, we are going to be able to solve this problem. Okay? Do not add the denominators, they stay the same. Add the numerators, 8 plus 3, and that gives us 11. All right. A lot of work, students usually say. They go, Mr. C, that was a lot of work to get an answer. And I say, you know what? You are correct. But do you see what we're doing? Can you see this in your head? What we are doing is we are taking two fractions that are different size pieces, and we're making both the fractions to where they have equal size pieces. Once they're equal size pieces, it's easy for us to add them. It's easy for us to be able to say, oh yeah, 8/12 plus 3/12 equals 11/12. All right, it takes a little work, but it is definitely simpler once we have this, because if not, you'd have to do a lot of work in your head, and that is where a lot of mistakes usually happen. Okay, so the answer is 11/12. Ask yourself, where'd you get stuck? Where'd you get lost? What didn't make sense? Practice. Rewatch this one if you need to, and try this next one. All right, join us. All right, next problem. We've got 2/5 plus 1/2. Okay, let's do this. Let's draw some models here. Need to represent 2/5. So draw two different models. Copy this one. Change the color. All right, now let's get to dividing these models up. First model needs to represent 2/5. So there's 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Shade in 2 out of the 5. So right now, ask yourself while I'm shading this in, are these two fractions, do they have the same denominators? Do they have the same denominators? No, they do not. So what we're going to have to do is we are going to have to draw these models here, and then we're going to have to go in and figure out how to create equivalent fractions that have the same, creating equivalent fractions that have the same denominators. So we're going to create an equivalent fraction for 2/5. We're going to create an equivalent fraction for 1/2, and the goal is that both of the equivalent fractions we make have the same denominators. Okay, so let's do it. I'm going to copy this and bring it straight down because we need to draw these models again in the goal of creating two fractional models that have the same number of pieces, equal size pieces, okay? So now that we have this, same thing, go ahead and draw 2/5. I'm going to do it vertically. You can do it horizontally, but I'm going to do it vertically just to stay consistent. So we're drawing 2/5 in this model. So in this model here, we've got 5 equal size pieces to start off. And we are going to create an equivalent fraction here in a minute, and we will see how many equal size pieces we create. In this fraction, we have 1/2, and again, I did these vertically. I've got to do this one horizontally, so go horizontally across. Color in 1/2. And we're going to create an equivalent fraction for 1/2, and we're going to see how many equal size pieces that creates, okay? So we've got our fraction 2/5, and we need to now represent 1/2 on this fraction. So what we're going to do is we're going to draw a horizontal line in to represent 1/2. That would be 1, 2, right? 1, 2. There's 1 out of the 2. Excuse me. There are 2 equal size sections. That's exactly what we had over here. 1, 2. Okay. Now on our fraction 1/2, we need to divide it into 5 vertical sections to represent the denominator of 5. So there we go. 1, 2, 3, 4, 5. 1/5, 2/5, 3/5, 4/5, 5/5. Okay. So now we've created equivalent fractions. All right, 2/5. We have turned it into an equivalent fraction. Let's see what that equivalent fraction we've created. That equivalent fraction is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 pieces. How many are shaded in? 1, 2, 3, 4. All right. So what we've done is we've taken 2/5 and we have created an equivalent fraction that is equal to 4/10. Okay. Now over here, let's look at 1/2. What did we create as the equivalent fraction for 1/2? Well, let me choose the right color first. All right, so for 1/2 here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal size pieces. How many are shaded in? 1, 2, 3, 4, 5. So what we have done is we have taken the fraction 1/2 and we have created an equivalent fraction of 5/10. Okay, now that we've done that, let's take a look at these equivalent fractions we've created and let's see if we're going to be able to add them. This denominator and this denominator are both 10, so that'll stay the same. Add the numerators, 4 plus 5, and that gives us 9/10. All right, how did we do that? Ask yourself, what was our first step? Why did we divide this model into 2/5 vertically and then 1/2 horizontally? Why did we do it the opposite over here? Okay, ask yourself those questions. And again, this here takes practice. Don't give up just because it's a little bit confusing right now. Stick with it, keep practicing it, ask yourself those questions. All we're doing is we're drawing models to help us see, 1, how we're creating an equivalent fraction, and then 2, how we're adding those, right? We had 4 pieces here, 1, 2, 3, 4, 4/10. We had 5 pieces here, 1, 2, 3, 4, 5, 5/10, and we just added them up and we got an answer of 9/10. All right. So, how you feeling? What you thinking? Getting stuck? Getting lost? That's fine. Remember, a growth mindset means that we're going to challenge ourselves. We're going to stick with it. We're going to keep working hard. Parents, teachers, make sure that you are asking good questions for students. Have them slow down. This will take practice. This will take a lot of time, all right? That is okay. Stick with it. Slow them down, all right? Take as much time as you need. Feel free to reach out to me. My contact information is at the end of this video. Also, perfect time for students to work on iExcel. Check out those links in my description. Free 7-day trial, 20% off memberships. Check those out. Also, if you learn anything new at all, make sure you click that like and subscribe button. Join us as we continue making math understandable and challenging. Thanks for watching. That's all I have for you today. Mr. C, out.